Hey, it's Mr. Salatano. This video is going to explain how to create the formulas for and how to create the names for ionic compounds with metals that have multiple charges. So before each metal just had one charge and that's all we had. Now we have metals with multiple charges. So remember we said before our main group elements, like the ones over here, we know the charges for, right? They're always the same charge. Same thing for most of this part of the main group elements, always the same charge. However, we said that this middle block varied, right? And we also said that this column right here varied. So we have to handle that somehow, and that's what this video is explaining essentially. We say that they vary because each of these metals in here and in this column could have multiple charges. It's not just one charge anymore. So let me show you what I mean. So just as an example, and here's just a condensed periodic table, iron could be a 2+ or a 3+. Nickel could be a 2+ or a 3+. Copper could be a 1+ or a 2+. So we have a lot of options with these metals, and we have to be careful when we do the naming. Same thing in this column. Tin could be 2+ or 4+, and lead could be 2+ or 4+. So we have to be very specific with when we go to do this. Now, why do we have to be so specific? Well, what if somebody asked you, go grab me some copper chloride, right? And then so you go to grab the copper chloride, you're looking around at the chemicals in the stockroom, and then you realize, wait a minute, copper could be a +1 or a 2+. And you're like, well, I don't know which one they mean, because we could be going with a 1+ or a 2+ to combine with our chloride ion, and we could get CuCl, or we could get CuCl2, depending on which copper we're using. And it's a very big difference, like I'll show you. Here actually on the left is copper with a 2+ charge, chloride, this distinct color, and then here on the right is copper with a 1+ and a chloride, and this is very, very different chemicals. So when you go to retrieve a chemical, you have to know what you're using. You can't just use random chemicals and hope it works out. And so this is why we have to use proper naming convention. Okay, so what do we do about this then? Well, the answer is that if an element has multiple charges, we use a Roman numeral in the name, not in the formula, but in the name we use a Roman numeral to indicate which charge we're actually using for that particular formula. So here's our Roman numeral 1, Roman numeral 2, 3, 4, and Roman numeral 5. So you're going to want to get used to those. This is actually kind of easy. 1, 2, and 3 are obvious. 4 is like that because it's 1 before 5. So that's a 4. V is for 5. And then you can imagine 6 is V and then an I after the V to show 1 after 5, essentially. Okay, so when we go to do this, let's actually give these proper names now. So our copper with a 1+ charge is called copper Roman numeral 1 chloride. So literally you say this copper 1 chloride. So more specifically, they should say, go to the stockroom and get me some copper 1 chloride. Then you would know what they were talking about. This other chemical is called copper 2 chloride because we're just using the copper 2+. Notice this has nothing to do with the quantity of copper. In either case, we have only one copper atom in the formula. The Roman numeral is strictly referring to the charge. So this single copper has a 1+ charge, and this single copper has a 2+ charge. That's really important. People tend to get that confused. It's just the charge. That's all the Roman numeral stands for. Okay, so let's try some examples. Let's start with binary ionic compound examples. Now remember, binary ionic compounds are compounds that are made of only 2 atoms, right? So binary, by 2, just 2. So let's make the formula for Fe3+ and Co-. So we go to make the formula, and that's what it would be. Now what would the name of that be? Well, the name would be iron, Roman numeral 3 chloride. So you would say that iron 3 chloride. What about this one? So for this next one, it would be, that's manganese by the way, and we would put 1 manganese with 3 oxygens to make this cancel. If you forget how to cancel, review our other videos. And so the name of this would actually be manganese 6 oxide because of that 6+ charge over here. And again, we only use 1 manganese in the formula, but that particular manganese has a 6+ charge. Okay. What about this one? So Pb is lead, so we'd end up getting PbF4, but in our name we would say lead 4 fluoride. And that's how you do that essentially. You just use a Roman numeral for the name. because that metal could have more than one charge, and you need to say which charge it's using. Okay, let's look at some ternary now. So remember, ternary have at least 3 different atoms in the compound. So we would have our Ni3+ combined with a nitrate, which is NO3-, and so we would get NiNO3, 3 nitrates to go with our nickel. And for the name, what would the name be? Well, the name would be nickel 3 nitrate. It's the same rules that apply essentially. We're still using the Roman numeral in there. And then finally, we would have, these two would cancel each other out perfectly, and then so we would have nickel 2 sulfate. So that's how you would name that one. Now, something you want to be really careful of, because this will get people. You do not ever use a Roman numeral if you have an element that's in the main group that only has one charge. You never use a Roman numeral, for example, for sodium. You only use Roman numerals for things that vary. The reason is because in chemistry we try to not be redundant. When we write our formulas, when we make our names, we don't want them to be redundant at all. It would be silly and redundant to say sodium 1 chloride, for example, because chemists know that sodium has a 1+ charge. It always will have a 1+ charge. It would also be silly to say magnesium 2 chloride. Magnesium is always going to be 2+. So just remember, never ever use a Roman numeral for something that only already has one charge. That would just be really redundant. So that's it for this video. Thank you for watching. Remember, chemistry is everywhere.